I hope you enjoyed the lunch, and I hope that I figure out how to work this thing. It has 2 buttons, back and next, so hopefully I'll be able to figure that out. Hi, I'm Sebastian. Thanks for the introduction to Niklas. I am a wearer of many hats in different contexts, and people keep telling me that I have experience with some things. Probably the most experience I have is being a Sebastian. I've been that for quite some time. I started doing things with computers in 1990. I was socialized and learned programming in the Amiga demo scene. I did 2D, 3D graphics in C and assembly. And I still try to do that today whenever time permits. Doing PHP since 1998. At the time, PHP 3.8.16 or 17 or something was the latest and greatest, but people were already working on PHP 4, and I got involved in the project fixing bugs, fixing the build on Windows, because back in the day I was still working on Windows, but have not been doing that for quite some time now. Got involved in the mailing list, in the documentation, and at some point, well, this is also since when I'm doing open source, and then in 2000 I started to work on PHPUnit, and I have not stopped to do so since then, because most of the time it's still fun. That's the one part, and the other part is I still think that this is an important infrastructure project for the PHP ecosystem, and I think I will work on this into the foreseeable future. Back in 2009, I founded a PHP consulting company together with Anne Blankers and Stefan Priebsch, and we help PHP development teams build better software and test their software and so on. Okay, so that's about as much of an ad as you'll get from me. I'm not really a marketing or salesy person. Maybe there will be something in the end, but we'll see about that. So I already mentioned where I learned to program, so I brought you a photo of my Amiga 1200, which I'm still using to this day. It still works. It's the machine where I fell in love with programming on. The photo is a bit outdated. I'm sorry about that, because since a couple of years ago, I have a really nice translucent keyboard that allows me to see inside the machine while I'm using it, which is sometimes interesting. And it was also, hello? I pushed the wrong button, sorry about that. It was also on the Amiga that I developed developed in air quotes, I created my first website. There were browsers on the Amiga, I could connect to the internet on the Amiga, there was FTP, I could get some shared hosting, I was able to upload some HTML. There was no CSS or JavaScript at the time, so it was just HTML. And whenever I was working on this website, I kept hitting the F5 key. Yeah, I made a change in the code, I switched windows to the browser, and I hit F5 to reload and look at whether or not the change that I had just done in the code had the desired effect, or if I once again had completely broken my website. Please don't go looking on archive.org or wherever, whether you'll find my website from 1994 or 1995. Please don't, it looks ugly as hell. And the information on there is quite outdated by now. But I was hitting F5 over and over and over again. Just like I'm hitting the next button, yes. And that was my feedback loop. And it was the only feedback loop, for web development at least, that I knew about at the time. And I kept asking around other people how they were doing that, and they kept telling me, yeah, that's just how you do it. You do something in the HTML code, and then you hit F5 in the browser, and then you see the effect. And that's basically how we work. And as long as there was no real software development involved, as long as it was only just static HTML pages, that's more or less good enough, because there are no side effects. I send a request, I get a response back, there was nothing happening on the server, there were no databases involved, no side effects, nothing that needed to be saved to persistence or loaded from persistence or talking to other systems. These were the early days, and they were quite boring when it comes to, hey, is there something that I need a more sophisticated feedback loop for? So fast forward a bit, I started doing things with PHP because one day I was contacted by someone that said, hey, I know you from the demo scene and you were doing programming back in the day, and now I'm doing websites, graphics with Photoshop and things, and so far that was all well and good, but now I need to write an e-commerce system and that sounds like programming and I cannot do that, can you help me? So I started learning programming and started to get into PHP, and I started to realize that hitting F5 over and over and over again was just not enough. Yeah, so we need to go deeper. Nowadays I don't need to do that anymore because, as I mentioned, I have a translucent case, so I can look inside, and we can look at what actually happens on the server. And don't worry, you're not supposed to be able to read this. Just suffice it to say, on the left-hand side, you have the index.php source code file from Shopware. And on the right, there is a PHP development web server running, listening on localhost and serving a local Shopware instance, and an HTTP client that shows the result, the response of an HTTP request to that Shopware stuff. So when you have a real application and not just static HTML that is being delivered, you suddenly have a lot of things that you may immediately be aware of. Hey, that's something that's a side effect that I would like to test. Like when I put something in the shopping cart, I probably want to keep track of that information somewhere, that even a couple of requests later, that item is still in my shopping cart. And when I hit the buy button and perform payment and money exchanges virtual hands in some third-party systems, it might be a really good idea that I have stored the information somewhere that this shop has sold that item to this person and it has been paid for and now needs to be shipped. And probably we should test that, and just hitting F5 doesn't work. So that's not a suitable feedback loop for that. This is not the feedback loop you want, and we can get a little bit geeky and say, hey, this is not the feedback loop you're looking for. So we need a different feedback loop. We need something that is more appropriate to keeping track of side effects and what goes on in a real web application. So, sorry to burst your bubble and to, miss some expectations here and there, but there's no automated way, there's no robot that can do that for us. But automation is a really good starting point to talk about this. So for quite some time now, there has been this idea of automating tests for software. Doesn't really matter if it's web applications or other pieces of software. Test automation is not something that is new, has been around for quite some time. And I was really lucky in the early 2000s that I had a professor at university where I was studying computer science, that he exposed us students really early to ideas like unit testing and test automation and test-driven development, and showed us JUnit. So JUnit was the second test automation framework that became popular. It was a successor to SUnit for Smalltalk, and about the same time CPPUnit was created for C++ based on JUnit, and PHPUnit was created by myself for PHP, because I learned about JUnit at university and I liked the idea of finally being able to consistently and continuously and with not really that much effort test my software and always have this nice feeling I know that everything I've done in the past in this project still works the way that I have understood so far how it is supposed to work, and at the push of a button can get this really satisfying feedback. You have not broken anything, since the last time you have run the tests. And then in small increments, I can add new code, new tests, run the tests again, and get the instant feedback. What you have just built still works, and everything that you built before is still working. So I created PHPUnit about 25 years ago because I wanted to have something like JUnit for PHP, because just the existence of JUnit was not enough motivation for me to switch my favorite programming languages, much to the despair of my teacher at university. Sorry about that. So I created PHPUnit, and like with any other type of framework, there are a couple of conventions that help you get started and help you conveniently and with as little effort as possible write what you want to get done, in this case, tests. So every test goes into a so-called test case class, and PHPUnit doesn't really care about how you name your tests, but you should care about that. Please don't do it in the way like the first customer that I ever had for training on PHPUnit did. 1 test, 2 tests, 3 tests, all the way to 10,000 and something. And they were complaining about the fact to me that when they ran their tests, a failing test would not tell them where something is broken. So do yourself a favor and come up with good names. And yes, I know naming things is hard, it's one of the hardest things in software development, but here, probably more so than in other areas of software development, it's time well spent, it's a good investment into the future. Future you will thank you for coming up with good names for your tests, and the rest of your team will thank you even on the same day. So when we want to test something that is called email, we write a class that is called email test. We extend PHPUnit framework test case, which is the integration point between your tests and the test framework. This gives you a lot of functionality to reuse, to express what you would like to verify in your tests. And a single test is a public method in such a test case class where the name begins with test. And once again, to really drive this point home, not test 1, test 2, test 3, but try to come up with a short sentence that precisely and concisely captures what you want to verify right now. So we are testing something that is called email. This is a value object, probably. I'm not going to show you the code because I try to talk about concepts more than technical implementation here today. So test can be created from valid email, and inside such a test method, and this was the huge step forward when SUnit for Smalltalk came along. Before that, we had tools that did not really use the language of the production code, so we had to use different languages. And the big idea of SUnit, and it's the same for PHPUnit for PHP, is that inside such a test, you have the full power of your programming language at your disposal, and you are using a language to express what you want to verify in the language that you already know. So we create an email object from a string, and then we use a so-called assertion method, in this case assert same, to verify that what we want to have happened has actually happened. The software behaves the way that we would like it to behave. There are many assertions that PHPUnit provides. I stopped counting them. It's a couple of dozen by now. If you get started with PHPUnit, do not get overwhelmed or even confused by the amount of features, especially assertions, that you find in the documentation. Trust me, you probably only ever need like, I don't know, 60 to 80% of the feature set that you will find in the documentation. There are a lot of features that only exist for very specific use cases. Some of these use cases were probably more relevant 10, 15, 20 years ago in older versions of PHP. and they are slowly being removed with long announcement cycles, like in 2 years from now, this feature will be removed, and then at some point it's gone, and life for everyone gets easier because you are no longer getting confused by looking at the documentation because there are features that you have no idea why they would be useful, because here and now they are no longer useful. They were useful 20, 25 years ago, and now they're gone. And it also makes the lives easier of those people like myself and others, like Fabian, for instance, who I see in front row, who work on PHPUnit, because if there are features, you need to take them into account when you want to make a change, and every line of code that you have that you do not need is a liability, and if you can get rid of that, that's good for everyone involved. So the first example shows how you can test return values. The second one shows you how to test exceptions. And congratulations, that's 2/3 of the things that you can test. And it does not get more complicated than that. It sometimes gets a little bit nasty with I/O and randomness and databases and global state. But ideally, if your code is clean, you never need to worry about those. Sorry, that's my attempt of trying to be funny. Okay, so once you have those tests, you can run these tests using PHPUnit's command line test runner. So PHPUnit is basically split in half. It gives you two things. It gives you the framework to conveniently write those tests and a tool to actually run the tests and analyze the results of the tests. So we run that here, and we see in a human-readable format, there is a concept called email in our application, and here are the things that we verify about that. It can be created from a valid email. It cannot be created from an invalid email. Maybe we could improve those sentences even more. Can be created from a string that contains a valid email, but then again, that already is a little bit longer, maybe too long. So try to find names that make sense for you, and if you are happy with the names, if they tell you the story that you like to tell through your tests, then that's great. They don't need to be readable for me, they need to be readable for you because you work with your tests every day, hopefully. So this is a feedback loop that I personally find a lot more useful. And over the last 25 years, I had a lot of success with this feedback loop, and you can do that even more extreme by actually writing the tests first, not after the fact, but writing tests first, and let those tests guide the implementation of the software that you're working on. That would be an even different feedback loop again, that's called test-driven development. So in the beginning, when automated software testing became a thing, the focus was almost exclusively on verification through execution. That's what we're doing here. We are running our software, either only a small unit of code of our software in isolation or the entire thing as a whole by installing the application on a server, sending an HTTP request, do all the things that the application usually does, and then you look at the HTTP response. There is usefulness in all different shapes and sizes of tests. But initially, that was only done to verify by running the software that the software works correctly. Over the years, we learned a lot more about how tests can be useful, because depending on when you write the tests and how you look at your tests, you not only have verification through execution, but you also have executable documentation. Remember the output from running the test from a couple of minutes ago? If I'm a new developer coming into the project and there is decent enough test coverage, I can look at that output when I have to use, for instance, for the very first time, something that is called an email or a shopping cart or a sale or a contract or a voucher. And I can look at the output of those tests and see, aha, this is what this thing is supposed to do. And behind every line in the output is an executable example that works. And nothing is more frustrating to me when reading documentation when the examples in the documentation do not work. So you have executable documentation that you automatically verify that it actually works. And if you do things a little bit more extreme and do test-driven development, let the tests guide the development of your software, then you have an executable specification for your software because you write the test first. In the form of a test, you document, you specify how you want the software to behave. And initially, that test will be read, and then you make a change to your software, and then you run the test again, and then it's green, and then you get the satisfying feeling of knowing, hey, I'm done with this next step. Something that I can no longer really understand was how I was able to work in software development before I was doing a lot of testing and a lot of test-driven development, because I never really knew when I was done. Oh, I can do this and I can do that, and maybe this would make sense. But forcing yourself to only write code that you need to make the next test pass goes to great lengths with regards to reducing the amount of code that you produce. And I think that's a good thing. Every line of code that I do not have is a line of code that cannot lead to a bug, to a security issue, become a problem when I want to introduce a feature that I actually need at some point in the future. And this may be surprising to some of you, but I really like that statement. Of course, I have to say that because I wrote that, sorry. But the primary task of a developer is not writing code, but to understand a problem. And in most cases, the solution to a problem may actually be writing code. Sometimes it may be like, hey, maybe we can make that problem go away without writing new software. And for me, personal, very subjective statement, the writing of tests helps me to understand the problem step by step. And over the years, I've met many other developers for whom it's exactly the same way. The tests do not drive the development as an end in itself. They drive the development to trigger the required thought processes. Sorry, you still need to use your brain thing and think about the problem, understand the problem, and oh my God, talk to people, ask them if you have really understood the problem, try to find a solution that just works, and then eventually write the code that does that. And once again, that is a feedback loop. And to give you an example that is much more closer to your reality than the trivial email object that I just showed earlier. If I say now I had a little bit of fun with the Shopware test suite last week, that could be misinterpreted. So I had a look into the Shopware test suite, and I was happy that I was actually able to run it, which is not often the case when I download software from somewhere that has a test suite and I can just run them. So thumbs up for that. So this is the test for a piece of software that's called Criteria Parser, and this is human readable output that hopefully makes sense to you, that you are the people working a lot with Shopware, and this is something with cheapest price and sorting and filtering for price sorting and things like that. And if you really want to understand how Shopware internally does something like that, run the tests for it and look at whether or not the output makes sense, and hopefully you will get a better picture. And that is what I mean by tests do not have only one purpose. It's not just for verifying that something works. It's also a really good tool and approach to document and specify software. There are many different shapes and sizes of tests. So far, we have barely touched the surface. What I've shown earlier is a so-called unit test. That means a test that tests one unit of code, usually an object, in isolation from everything else, which is really easy to do if that object that you're testing does not have any collaborating objects. There's no other dependency that it needs to talk to. It does not invoke a method on a different object and so on. Gets a little bit more, not complicated, but a little bit more work if you want to test an object that has a dependency on something else in isolation from that something else. Unfortunately, I do not have time to go into too much details there, but the keywords are test stubs and mock objects to test the communication between collaborating objects and to isolate collaborating objects from each other when you want to test them in a unit test. And then one level up, we have so-called integration tests. Those can be testing two collaborating objects really collaborating with each other. That would be probably the smallest possible integration tests, but they can also be much larger. Like, for instance, you test a piece of code, a unit of code that takes some data and writes it to the database and reads it back from there, and you want to make sure that talking to the database works correctly. That is also considered to be an integration test. Then you can make it even bigger and test so-called edge-to-edge, like you somehow instantiate your HTTP framework or your Shopware application inside a PHP unit test and basically use the API, basically do what you normally do in your index.php file of your Shopware application, for instance, and say, please run the entire application given that this HTTP request has just gone in, and then the application does whatever it is doing, talking and using all those dependencies and coming back with an HTTP response. And then you look inside the HTTP response, does it look like it's supposed to be looking? And additionally, you also look inside the database, have the changes been made that I'm expecting, have no changes been made that I'm not inspecting, has a file been put somewhere on disk, whatever side effect you're interested in, but without making a real HTTP request and using a real HTTP server. That's what is called an end-to-end test, where you use a real HTTP client, make a real request, get back a real response from a real server, and look at that. And there's even larger tests that you can do, but you usually don't need those. I did not really promise, but I gave a little bit of warning that there might be some ad in the end. So my company, we offer an education flat rate where you can get a seat for one developer, for instance, for 200, 250 hours of interactive training throughout the year. And one of the formats that we have is the Tester's Corner, where I once a month talk about a testing topic. And I would like to invite you to come there if you like to the next edition of that. That's next month on June 6th. Sorry, it's in German, so if you're still welcome to join even if you do not understand German. Come along and we'll have a good time talking about best practices to test randomness and time-sensitive stuff. And with that, thank you. I hope I got my excitement about testing across and interested in you in trying to get started with automating tests for your software solutions. Thank you.